Hi everyone, today we are going to build the KNN from scratch using Python. We will use a classification dataset and our goal is to predict the correct class for new unseen samples. KNN is one of the simplest machine learning algorithms. The main idea is that when we want to classify a new sample, we look at the nearest training samples around it, and then we assign the class that appears most often among those neighbors. So, in this lesson, we will not use any ready-made KNN library. Instead, we will build the logic ourselves step by step so we can clearly understand how KNN really work behind the scenes. Before training the model, we will load the dataset from Google Drive in Google Colabs and prepare features and targets, and we will split data into training and test sets and standardize the values and then implement KNN using distance calculation and majority voting. So now let us start with the code. In the first cell, we need to connect a Google Colabs. So from google.colab, we want to connect Google Colab to Google Drive. So we will import Drive and the drive dot mount content and we will run the cell. Yeah, instead of dot, we put a comma here on the dot. Exactly. So we need this step because our dataset file is stored in a drive, so Colab needs a permission to access to drive. Now we need to import the main library, for example, NumPy and Pandas and Matplotlib library. So import NumPy as NumPy, import Pandas and UD, import Matplotlib library as PLT. After that, we need to load the dataset from Google Drive. So data frame of df equal pd.read.csv, and we need to change this direction where we put our dataset. So I put it in my drive here, and I made machine learning KNN, and this our dataset. So copy path, and we will just put the path here. After that, we will print the shape to know how many rows and columns it has, and we will print the column names and display the first 5 rows, for example. So we need to print shape and print \n columns and print TF columns dot to list. And we will print the first five row slash first five rows. We will display, for example, or we can use a print df dot head, or we didn't use anything. So we have these columns, and we have the shape 1000, and we have 12 columns. So we need to remove the column called unnamed 0 because it is just an index-like column and does not help the model to learn. So we need df equal df dot drop columns and unnamed. Then we need to separate the dataset into feature and target. The feature are all column except target class, and the target is the class we want to predict. So features columns equal dot columns column not equal target class. Target equal target class. So we need to convert both parts into NumPy arrays because our KNN implementation will work directly with NumPy. So x will equal df for feature columns dot no NumPy, and the type will equal float, and y will equal df for target column and to NumPy, and the type for it, data type for it, integer, and we will print shape of x and shape of y. Okay, so now we have 11 column only, 10 column for feature and 1 column for target. After that, we need to create our own train test split function from scratch, and we made it before. So we will create train test split NumPy, and it will take x and y and test 0.2 and seed equal to 2. RNG and b dot random default RNG seed and samples we would take it from the shape 0 and it's equal and b dot array for unsample and we need to make a shuffle and test count will equal int for unsample multiplied with test size and test indices. We will take from first to test count and for trend indices we will take from test count to final to last. After that we need to xtrain equal xtrain indices and xtest will equal xtest and y test will equal y test indices and we will return xtrain and xtest and ytrain and y test. So these will equal trend set number and we will pass x and y and test size will equal 0.2 and it will equal 42. I didn't explain too much because all of these code we explained it before. And we will print the shape for x train and x test and y train and y test. Okay, has no attribute arrange. With one R. I'm sorry for that. Okay. Now it's working. Now we need to make a normalized for the data. KNN depends on the distance, so scaling is very important. If one feature has much larger value than another, it can dominate the distance calculation unfairly. So we need to compute the mean and the standard deviation from the training set only. Then we will use those same values to scroll both training and test data. So we need to make train mean to calculate the train mean x train dot mean and x equals 0 and train std. We made it before and you can take the code from the previous example. std will equal md dot where train std equal 0. So that we will make xtrain equal xtrain minus xtrain mean divided by train std. and x-test will equal x-test minus train mean divided by train std, and then we will print first three rows standard standardized x-train, and we can print the value here to see it. After that, the most important step, we will need to define a function for Euclidean distance formula. So we need this for Euclidean distance, and it will take x1 and x2, and we will return mp dot square root urt. It will calculate the square root of the sum of squared distance between corresponding features. So mb.sum x1 minus x2 to power 2. And we need to run it. After that, we will create a function for predicts the class for one test sample. First, we need to compute the distance between the test sample and every training sample. So we need to make definition for KNN predict single, and it will take one and y terrain, and this, and for example k equal 5. So we need to calculate the distances and put it on the array. For I in range len xtrain dot shape 0, we will calculate the distance. Distance will equal equivalent distance for xtrain for I and xtest. And distance will append distance and y train of I, and distances dot sort key lambda is equal to 0. We need to sort all distance from smallest to largest. After that, we will take the label for the nearest k neighbor. Finally, we need to count which class appears most often among them and return the class as predicted. So, to complete k nearest neighbor or nearest labels will equal exactly, and after that unique label will equal and b dot unique. Answer true and predicted levels will equal unique level and b dot mathematical counts, and we will return predicted level. So in this function, we compute the distance between the test sample and every training sample. Then we sort all distance from smallest to largest. After that, we take the label of the nearest k neighbor. Finally, we count which class appears most often among them and return that class as prediction. After that, we will make a new function. It's called KNN predict, and this function expands the previous idea from one sample to all test samples. So we need to define a new function. We can predict will take x train and y train and x test and k equal 5, and we need to make a predictions for I in range len x test dot shape 0 prediction will equal KNN single x train and y train and x test for I, and k will equal k, and we will make a print for the predictions and we will return the array. So as we said before, this function expands the previous idea from one sample to all test sample. It loops through each row in the test set predicts its class using the single sample KNN function and stores the result in a list. At the end, it retains all prediction as NumPy array. In this cell, we will create a simple accuracy function and it compares the true labels and the prediction label. So define accuracy score NumPy y true and y predict, and we will return b dot mean y true equal y predict. So it compares the true labels and the predict labels, checks which prediction are correct, and it then compute the average. So the result is the proportion of correct predictions. Now we need to test the KNN model using one value of k. For example, k equal 5. So the model will predict the classes of the test set. Then we will measure the accuracy and it will give us the first idea of how well KNN perform on this dataset. So y predict will equal KNN predict, and we will pass x train and y train and x test and k equal k, and accuracy will equal accuracy score NumPy, and we will pass x, y test and y predict, and we will print Okay, and we will print the accuracy. So we need to ensure from the code it gives us object of type integer has no length. Okay, we need to correct one code. Okay, so we will delete only the name here. And we will try again. Okay, also this. I read the error and I solve it really. So the accuracy we have it 93%. But instead of testing only one value of k, we will try many value from, for example, 1 to 20 for each value of k. We will predict the test labels and compute the accuracy and store the result. So k values will equal list range from 1 to 21, 20, and accuracy. So we will make a for loop for k and k values. Y predict equal KNN. Y predict for this k. X train and Y train and X and k would equal k. And we need to calculate the accuracy for k, and we need to append the accuracy of k. After that, we will print k equal, and we will take only 2 digits, and accuracy. Okay, we need to take 4. So we will predict the test labels and we will compute the accuracy and we will store the result. This helps us to find which value of k works based off this dataset. So for example, when we have a k equal 1, the accuracy 94, and when the k equal 2, the accuracy is 90, and etc. for all of these k values. We need to plot a figure. For example, figure size and 6, and we will plot k values and accuracies, and we can put a marker equal O, for example, and we will put a title KNN accuracy for different k values, and x label will k, and y label the accuracy, and we will need to plot dot show to show it. So it gives us the relationship between k and the accuracy. The x-axis shows the value of k, and the y-axis shows the accuracy. And this graph helps us to visualize, identify the best region for choosing k. So we have the best key k here. So we need automatically to find the best value of k. So we need to best index will equal int for mb dot argument for accuracies, and best k will equal k values for best index, and best accuracy will equal accuracies for this best index, and we will print the best k and the best accuracy. So we have best k equal 17 and best accuracy equal 96. We can also print the confusion matrix, and we can make confusion matrix without any library. We can write it. TB will equal B dot sum for y 2 equal 1, and y predict equal 1. And we have also Tn equal MB dot sum so we need to ensure from that Cn equal y true and equal 0, and y predict equal 0, and if b will equal false positive, it's equal y true equal 0, and y predict equal 1, and the reverse, and we will return mb dot array for all of these. P on FB, and Fn. So this was predict will equal KNN. Predict string and best of K and confusion matrix will equal confusion matrix, and we will print confusion matrix. So we build a confusion matrix from scratch, and it tells us not only how many predictions were correct, but also the type of error made by the model, and it separates result into true positive, true negative, false positive, and false negative. And we can also print the recall and all of these, and we can print only test model in one sample only. We will take the first sample from the test set, for example, and we will predict the class. So sample will equal test of 0. And for example, we want to show it before. We have this value for this sample, and we need to predict it. And we need to print the prediction for it. For first sample, prediction, and we need to print also actual. Yes, and test for this. So the predicted class for first test sample equals 0, and the actual class equal 0, 0. So thank you. I will explain also in the next video. I will explain SVM support vector machines. Thank you all.